So we're going to talk today a little bit about how to draw tangent lines on a position versus time graph. The goal here is to be able to find how fast and what direction an object is moving at different clock readings when it's speeding up. The first thing you'll need to do is build your position versus time graph, plot your points, and you'll need to plot a best fit line or best fit curve to your slope. Now to do that, it's easier to do it with a pencil. I'm going to give this a shot with that's pretty horrible, but that's what we have for right now, so that's what we're going to go with. So the idea here, again, is to figure out what the relative angle of the line is at 1 second, which would be, I'm just going to sketch this out right now. It's not going to be a good slope of a tangent line or anything, but basically, notice the angle of the line at 1 second is about like this, but if you look at it at 4 seconds, the angle of the line is much steeper. At 6 seconds, again, it's even steeper. So we're looking at the relative steepness of the slopes, telling us the relative speeds at those moments for this uniformly accelerating object. So we'll get rid of those. Now, when you draw a best fit line, you should use a ruler or a straight edge of some sort. And basically, you just want to draw a line that is reasonably close to the steepness of the line. Now, it can't go through the curve, so this wouldn't work. And you should not assume that most of these tangent lines are going to go through 0, 0. I'm just trying to adjust this so that the angle of the line at 1 second is at the same angle as the curve. So if I take that and bring it up just a little bit closer and bring it up so it just barely touches it. Once you've done that, you can find two slope points along there, mark those, and use rise over run or change in position divided by change in time to calculate those slopes. Just looking along here, it looks like we've got a pretty good slope point here that's, I don't know if these are lined up perfectly right now, but it's like 4.9 seconds and around, that looks like it's about 40 centimeters, and you'd have to find a second one. This one looks pretty good, about 3 seconds, and that's at 5, 10, 15, 20, 25 centimeters at 3 seconds. So you could use that, do change in position divided by change in time. You could feed it in there, change in position divided by change in time, and get the corresponding velocity. So let's take and see how drawing a tangent line at 2 seconds might look different. Now, we could leave that on there, or we can try to set a second one up at 2 seconds as we go. I would prefer that you keep all those lines on there so we can see the slopes of those tangent lines. Now, I drew this earlier to try to get a slope of the tangent line at 2 seconds, and that's pretty close. But let me show you a cheat that is based on the discussion we had the other day about my nieces and nephews all having the same birth date and the average age of the kids equal the age in the middle. If we want to find the slope of the tangent line at 2 seconds, consider the 1 second point and the 3 second point plotted before and after it. If we connect those 2 points and then extend well beyond there, so notice I'm still connecting my points at 1 and 3 seconds, and then I'm going to go ahead and extend this line down the other direction so it's coming off the curve, but we've gone through the point at 1 second and the point at 3 seconds. Now if I can grab that line and bring it down, it should be reasonably close to the shape of the curve at 2 seconds. And I might make a small adjustment. But remember, it has to run alongside the curve. It cannot pass through the curve. Never are we going to have this. Or you don't just go from 0, 0 to like 4 seconds or something like that. We can't take those approaches. So you just adjust the line so that it's the same steepness of the curve at that time. I'll do this one more time at 3 seconds. So at 3 seconds, maybe what I could do is connect the points I plotted at 2 and 4 seconds, which should give me close to the right angle. Go ahead and click on that and extend that line out this way so it goes off the curve. and this way so it comes off the curve. Oh, and I forgot to do this earlier. I just noticed that V3 sat at the end of that line. It's a good idea to mark your tangent lines when you finish drawing them. So this would be V2, so because it was the slope of the tangent line at 2 seconds, which tells me the instantaneous velocity of 2. This tangent line was, that gives me the instantaneous velocity at 1 second because it was a tangent line we drew to the 1 second mark. Anyway, I hope that helps.